So, okay. Final exam will be on Monday. Let me just pull up the calendar for summer. Okay. Specifically, yep, summer 2022. So final day, final last day of class is Monday. That's when I'll get the exam. I'll be happy to take demos that day or even on the next day, which is Tuesday the 2nd. Grades are due August 4th, so I will try to have that in, by then. That's probably when I will actually have your grades in. I'll discuss how my curving works in a bit, but that only helps students and doesn't hurt them. Doesn't necessarily come up too much in summer. And I will also go over the last homework, which again, you don't need to do if you've done all the assignments, since I will be dropping the lowest score. Okay. So curving, the way that the curving works, let me create a whiteboard because I'll be doing a lot of whiteboard today. There we go. Share screen, Microsoft Whiteboard. Okay, so the way that this works for this class is, in a normal semester for the curve, is that I'll look at my scores. I get all the scores in, put zeros in for the assignments that weren't turned in, and then I arrange the scores from highest score to lowest score. Don't really care who got what. I'm just looking at the scores. And then what I do is that basically I've already written in my syllabus that if you've got a 90 or above, that's going to get you an A no matter what. Not an A minus, an A. Same with if you get greater than an 80, that's guaranteed to be a B, not a B minus. And C and 70s are greater than C. So the question is, where do the plus minuses come in? That's where those come in. And those basically extend the ranges of grades. So what I'll do is that I will again range those from highest to smallest. And I'll look at this and I'm saying, okay, we've got a 90.2, a 90.5, and an 89.8. And I'm like, there isn't too much of a significant difference between these two. And also there's just not a big, and it's almost an A. And same over here with this 89 point 0.5, 89.3. And then if the next grade is an 87.2, that's a fairly large gap compared to the other gaps. So what I'll do is that I'll typically set, let's see, a 6.1. Yeah, this is a good example here. So what I'll do is I'll say, okay, as stated in my syllabus, everything above this line is an A. These are going to all be A minuses. And then this was almost there at the A. So that's going to be our B plus. Does that make sense? And I essentially do this for all of our ranges. So the minuses are used to bump people up who were basically on the verge of getting something. And and so that's what the minuses are used for. Since that is a, that's a significant difference to GPA. Okay. That said, in general, you do need above 70 to pass. So that is important, but generally none of your grades get adjusted. none of your raw grades get adjusted. It is all your raw grade, and then it is just simply what does the raw grade output to. Generally, also, I don't do C minuses, because the C minus, it's either going to be C minus or a D. Last but not least, if you take your, the only way to get an F in this, there's only 2 ways to get an F in this in my classes. The first is to not turn anything in and not do the final exams, basically just stop halfway through. In other words, just give up. You give up, you get an F. Or you don't participate, you get an F. The other way to get an F is to cheat. Those are the only 2 ways to get an F in my class. This is because of a long-standing dispute I have with the academic, with the instructions that are given to me by the academic financial assistance office with regards to the way, financial aid, FAFSA works for students who get Fs in classes and they need the last reported date, but then the instructions for what if you don't have the last reported date of the student are contradictory for what actually happens, which is, it was a whole thing. And so that's part of the result. So, but if you do try then, and you fail. So if you take your final exams, and you try to turn in your homework, you're getting a D guaranteed at least. Okay. So D's are, so because a D doesn't pass you, but it's not necessary, but it's not as it's a 1 versus a 0 for GPA averages. So that does make a bit of a difference. So now let's talk about the final assignment, if that is one you decide to do, because it's a lot of fun. It is Project Euler 79. And I'm not sharing my screen for Project Euler, but that's fine. Actually, why not? New share, the entire screen. Project Euler 79. Passcode derivation. So a common security method, it's not used for online banking, is to ask the 3 random, ask these for 3 random characters from a passcode. For example, if the passcode was, if your password or passcode that they assigned you was 531278, they may ask you for the 2nd, 3rd, and 5th characters. So you are expected to punch in 317. There's a text log where somebody has exfiltrated 50 successful login attempts. Given that the 3 characters are always asked for in order, so it's always going to ask you for the 2nd, 3rd, or 5th, but not the 3rd, 2nd, then 5th, or the 1st, 6th, and then 2nd, right? It's always going to be in order. So you could do 1, 2nd, 6th, or 5th, 6th, 8th if yours is 8 long. Right. Given that the 3 characters are always asked for in order, analyze the file so as to determine the shortest possible passcode of an unknown length. Well, since there's 10 digits, we know that this thing can't be longer than 10. Or it shouldn't be longer than 10 because otherwise it becomes way too difficult to analyze. So this is a graph problem disguised as a security problem. So we've got these numbers. And the question is, how do we reconstruct this passcode from these numbers? Well, the first thing we do is that we can encode this in a graph, because what these numbers tell us is a relationship between these numbers. Specifically, it is telling us that this first one tells us that a 3, a 1, and a 9 are in the password. Okay, so the numbers are our nodes, right? A graph is a thing that talks about relationships. So we know the things that we have, things that are in some kind of relationship in this graph. A 3, a 1, and a 9. So now the question is, the edges tell us, our answer the question, what is that relationship? And in this case, the relationship is that you have to punch in the 3 before you punch in the 1, before you punch in the 9. In other words, the 3 comes before the 1, and the 1 comes before the 9. And it also implies that the 3 comes before the 9, but we don't necessarily need to encode that. So we can draw our graph like this. 3, so you can make the numbers a node, and then the edges are saying 3 comes before 1, and 1 comes before 9. If I were to name this, by the way, if I were to name your edges, because you have to do that in Jung, I would name this edge 31, and this or 31, and this edge 19. This is because with Jung, when you add an edge to a graph, then it asks you to put in basically, okay, you've got a node, you've got node 1, you've got node 2, or vertex 1 and vertex 2, and please tell me what the name of the edge is, or what. And you can't add an edge. And what you want to do is that the program crashes if you try to add in an edge, a new edge between two nodes that already have an edge. So if you tried to add in a second edge, unless you try to add in an edge with the same name. So if I put in, if I try to do 3-1 V2, this would crash the program. But if I just answered 3-1 again, it would just go, that already exists. Ignore it. Because only one edge can exist between two numbers. So by giving everything basically the string name of source destination, it works for just automating the process. Anyway, but what am I going on about? So we've got 3-1. No, darn. Menu bar. No, correct. Oh, well. Sometimes. Okay, so 319. So we have the next batch of numbers, which is 680. We can erase the names. We don't need them. And then the next number was 180. So the 80 already existed, but now we know 1 comes before 8. Next one is 690. So 6 goes all the way over here, and then the 9 points to the 0. And then we have 129. So we know that the 1 comes before the 2, and the 2 comes before the 9. 620. So 6. Let's see. So let's go ahead and whoops. So let's go ahead and redraw this, try to make it as much of a planar graph as I can. So 690 was one we did. And now I'm going to go ahead and I'm just going to take this 2 and pop it out over here. Because we had 129, 690, 620. And unfortunately, I don't think I'll be able to continue making it planar. What do I mean by making it planar? Anyone? Does anybody know what it means?
Oh, sorry. It means none of the edges overlap, right? Yep.
So yeah, exactly. A planar graph has this mathematical equation associated with it, courtesy of Euler, I believe. But it means that for purposes of neatness, I can't, if it's planar, I'll be able to draw it without having to worry about any of my edges crisscrossing over each other. 720. Sorry, 762. So 7 goes to 6, goes to 2, 6, 8, 9, 6, 8, 9, 7, 2, 0 is already, sorry, 7, 6, 2 is already in there. 3, 8, 1 and 3, 1, 8 and 3, 6, 8, 3, 1, 8, 3, 6, 8. And then 7, 1, 0. And then 7, 2, 0. Okay. And then 7, 1, 0, 6, 2, 9. And 1, 6, 8. I'm looking for another one. Okay, 6, 1, 7, 1, 6. 7, 3, 1. That is kind of what I was looking for. 7. Whoops. Seven, 3, 1. As a input there. And then 7, 3, 6. So the point of doing this, of creating this graph, is because what we've got here is a directed acyclic graph, a very messy directed acyclic graph, but it's a directed acyclic graph, a DAG for short. So directed, so acronym time. So right, directed acyclic graph. Right? So what does directed mean? Directed means that we've got directed edges. We understand what that means. And we understand that it's a graph. Acyclic is the only weird word that we don't know. But a cyclic graph means it has cycles. And the A in front of it means none. So this is acyclic. It is a directed graph with no cycles. Holding it holds a much near and dear and traumatizing place in my heart, since my qualifying exam was all about directed acyclic graphs. So let us continue. So directed acyclic graphs, right? So the thing about directed acyclic graphs is that you can use this topological sorting on them. And topological sorting basically lets you know what goes first, like what order these things are processed in. So the way topological sort works in the videos is that I go over something called Kahn's algorithms, and it's very simple. Basically, you get all this stuff, and the meat and bones of it is you look for the node that has no incoming edges. And the way you can do that in Jung is that you can ask for the in-degree of a node, which requires me to move over just a second to tell you what in the world is in degree. So we've got a node. Okay. Okay, move yes. So we've got a node. And a node can have an in degree and an out degree. So an in degree is this. It is the, sorry, an in degree is this. It is the number of nodes coming, number of edges coming into the node. So in this case, this node has an in degree of 2, and it has an out degree, the number of edges that are leaving it, of 4. Okay, and so what we're going to be looking for, given a graph, is basically we'll be asking for the in degree. So given a graph, we're asking for the in degree of some vertex V. And we're asking, hey, if that's 0. That tells us if a graph has no incoming edges. If a graph has no, sorry, if a node has no incoming edges. If a node has no incoming edges, that means that it's got to be processed first before anything else, because you go from there to anything else. So now what we do is that we go and we start. So what we're going to do is that we are going to mark down 7, and then we're going to remove 7 and all of its outgoing edges. Removing a node from a graph generally will remove its outgoing edges, by the way, so you don't have to manually process that. So we remove 7. So we know 7 is the first number in this password. Then we just repeat the process while there's still nodes in here, which of these nodes has an in degree of 0. 3 did. So 3 is the next number. Now here we're getting into an issue, which is an ambiguous situation. Basically, both 1 and 6 have no incoming edges. But for this problem, this should not happen. In general, what you do is you just choose one randomly because it's ambiguous. You just choose whichever one you want. But because we are creating going for a password that has an answer, and that answer has to be specific, we have to actually have we actually have to have a single number. And so if you process all of the data, if you process all 50 of the numbers, you'll get a situation where when we start removing nodes, it's going to be completely unambiguous. Okay, if you want to check your answer, it does start with 7.3, and you can just check it by creating an account at Project Euler. And then that will enable you to type in passwords for the answers. All right, finally, for the exam. As a reminder, the practice exam, you'll want to refer to the, let me go ahead and show you on Canvas. Share screen. So go to your Canvas course. And then go over here to lecture recordings, right over here. Click on it and go to one of the previous semesters. And watch the final exam, part 1, final exam reviews, where I go over final exams from other institutions. It's generally the same each semester. So you'll just want to go down. If you're having trouble with a couple other things, then you might find that this one had a lot of days where I reviewed stuff. So, just feel free to go ahead and peruse those, because those are relevant to the final exam. And what I'm doing there is I'm going over in other institutions' final exams. All right. Anything else before I split us up into breakout rooms? If you still need to take the second exam, then be sure to reach out to me or let me know when I come to a room.